Welcome back. In this video, we'll look at convolution 1D transpose. And for this, here is what we need. We need an input. So let's create an input array. Input, and for this input array, we can look in the docs what the shape should be. So I have it open here. And if you look at the shape, as we had before in convolution 1D, we have similar shape. And then we also would need shape for the filter, and again we can look in the docs for the shape of the filter, and we see that this is width, output channels, and in channels. So let's put that here. Now we can create a tensor for input. So let's say x is the tensor, tf dot constant, and here we are going to keep things simple. What we'll do is we'll create a tensor. It's 1 by 1 by 1, and if we look at the shape of this, print x dot shape, we see that it's 1 by 3. Now what we need to do here is 3 is our width, 1 is the batch. We also need to add the in channels to this. So we need a 1 after 3, and for that we are going to add dimension by adding square brackets around this one. So now we have the required dimensions. Likewise, we need to create a filter. So let's create a filter f that is equal to tf dot constant. And again, this filter has, let's say it just has a width of 2. And let's now look at the shape. Print, uh, uh, print, sorry, print x f dot shape. And here we see that this is 1 by 2. What we need here is we need the width of 1, so 2 should be the first one, and then we, let's say the output channel is 1 and the in channel has to be 1 because it has to match the input. And for that, what we can do is we'll put this inside of the square brackets. So what that does is it changes its shape to now 2 by 1, and we need additional dimension on here on the right hand side. So we'll add another set of square brackets around this, and so that gives us the shape of 2 by 1 by 1. Now before we write the code, let's look at how we could perform this calculation manually. And for this, imagine we have this set of pixels with values of 1, 1, 1, and that's the array we have right here. And at the same time, we have another filter. So let's say we have a filter which is right here, and that filter has a value of 1, 2 that we have shown here. Now, when we perform the convolution operation, what we are now we are what we are trying to do is transpose convolution 1D transpose, and uh, in that case, here's what will happen. For this first pixel, we are going to multiply 1 by 1 and 1 by 2 and put the output right here, and the output is going to be 1 by 2. Again, for the second one, we are going to multiply 1 by 1 and then 1 by 2, and so the output we get is again 1 by 2. And finally, for the last one, we again multiply this one with this one, multiply this one with this two, and we get the output of 1 by 2. Next step is to combine these. So we are going to add these numbers right here, and we are going to add these numbers. So the 1 stays as is. 2 plus 1 becomes 3, so we have that here, and this 2 plus 1 becomes 3, that's there, and this 2 stays as is. And so what we have is a transpose of one convolution 1D transpose. And as you can see, the shape now has a width of 4. So we'll try to use this logic, this shape in the code that we'll write now. So for that, let's let's type the code right below this. And this is going to be a result. Let's create a variable. Result is equal to tf.nn.conv1d underscore transpose, and in this we need the input is equal to x, then we have the filters is equal to f, and then we have output shape. So output underscore shape is equal to 1 by 4 by 1 by 4 by 1, and then we need the strides is equal to stride of 1, and we have the data padding. So then we have the padding is equal to, we'll keep the padding set as valid, and then we have the format data format is going to be n, that stands for the batch, then you have the width and the channels, and finally down here we'll print the shape of result, and we'll print we'll see the result in the output. So let's convert it to a numpy array and run this. So as we can see here, so let me zoom in a little bit. So what we have is the values 1332, and that's exactly what we had, 1332, and um, that is based on the inputs that we had. So that was the input shape, that was the shape of the filter, and that's the output shape. So this is how we can perform convolution 1D transpose in TensorFlow. If you have any comments or suggestions, please do let me know in the comment section below. I hope to see you all in the next video. Thank you.